first things I introduced to the teachers in the Champions of Maths program is a basic classroom structure for our lessons. This structure consists of three things: a three-phase problem-solving lesson, the use of large vertical whiteboards, and random groups. The three phases of the lesson are launch, explore, and discuss. In the launch phase of the lesson, the teacher introduces a rich, mathematically demanding task. They do not model likely solutions, but they may give explanation of some understandings or concepts that are necessary to take on the problem. The problem that the teacher is giving here to the students is, what is the sum of all the odd numbers from 1 to 99? During the explore phase, students attempt to solve the problem. They work together in groups of 4 usually, 4 being the optimal size because groups larger than this tend to have students that can't engage, but with a group of 4 it allows for a lot of different interactions, and people tend to talk in pairs, so this means that the group can pair in multiple different ways without anybody being left out. There is research from Peter Liljedahl from Simon Fraser University in Canada that shows that randomly assigning the groups and the use of vertical non-permanent surfaces is highly beneficial to promoting thinking behaviors within the classroom. The use of randomly assigned groups is basically to take away any judgment in the group, that the students might feel that they are in the dumb group, or that they are in the smart group, or that they are being separated from their friends. It is the most socially acceptable option simply because it's the roll of dice, figuratively speaking. The use of vertical whiteboards or vertical non-permanent surfaces, so these could be windows or other surfaces that are erasable, is very powerful. The verticality means that it's much easier for students to work on them collaboratively because they can see each other's work at the same orientation. Whereas if they're sitting at a table, if one student is writing, it's upside down for the other student or sideways. The verticality also allows them to stand close to the boards and move away from them, and students will do this depending on what type of thinking they're engaging in, whether they're doing a calculation or they're looking for a larger pattern, then they might stand back. The non-permanence or erasability is coming out of that research, and that research showed that the difference between groups who work with a permanent surface and a non-permanent surface in terms of how long before they first make a mark is on average about 2 minutes. So that's a lot of lost time if we're using permanent surfaces for students to start getting going. The reason that's proposed that students mark or write sooner with an erasable surface is the sense of safety, the fact of the feeling that they know they can rub it out, even though most of the time they won't. I've heard students in lessons that I've taught that have said it helps them be more alert standing up at the boards and gets their blood pumping, and I think that it gives a transition and a kind of ritual to a different space when now I'm moving into problem space, standing up, focusing. In the discuss phase, groups present their solutions to the whole class. Usually this will just be 2 or 3 of the groups that this teacher will select depending on what they want to highlight to the class. The whole class will discuss the mathematics that comes up in the solutions together, and the teacher will make connections and help the students make connections, as well as using various talk moves to involve all the students in the conversation actively. We'll talk more about these discussion techniques in later videos, but for now, just notice that the boards have been moved to the front of the room, and we definitely want to make this a very serious focus on what the students are saying. This is not a show and tell but we really want to pay attention to the students' ideas, and we want to promote the idea within the whole class that what the students are presenting is really ideas worth considering, and that if we all consider these together, our knowledge in mathematics will deepen. Question: how do the structures explained in the video convey the desired messages of the Champions of Maths program? Here are those messages again.